High dynamic range images are a recent development in computer graphics. They're starting to be used a lot in the film industry, and they have applications in AEC as well. The idea is simple. HDR images capture more information than can be displayed on the screen at a given moment. In the real world, your eyes can perceive a wide dynamic range. That means that you can see details in the shadows, midtones, and highlights at the same moment. When you use a camera to try to capture a scene, it compresses the dynamic range. That means that some of the details are lost either in the shadows or the highlights. Because of this, photographers often bracket shots, meaning they take multiple exposures at different shutter speeds or f-stops to capture pieces of the dynamic range. Then they can combine all of these shots into one image in Photoshop. Here I am in Photoshop CS3 Extended with an HDR image displayed. It looks like the highlights are completely blown out. There's no detail because these pixels are all white. However, this is an HDR image, so there's a lot more data in this file. I can move this slider to move through the dynamic range, and you can see that there's a lot of detail in the shadow, and when I change the exposure down here, you can actually see the building across the street. We can use HDR images in 3ds Max and Viz. Keep in mind that HDR images are more than texture maps. They store lighting intensity levels as well as color. So they're useful in image-based lighting and in creating reflection maps. I'm going to switch over to 3ds Max and open the Interior 3 sample file. I'll focus on making an HDR reflection map, and I'll put it on this teapot down here. Open the material editor and sample the material from the teapot. It has an anisotropic shader because it's going to be shiny. The Maps rollout reveals that there's a ray trace map in the refraction slot. That's what makes the teapot look like glass. Now I'd like to do a comparison between a regular bitmap and an HDR bitmap in the reflection slot. Let's start with a regular bitmap and see how it looks. I'll click on the None button right here and use a bitmap. I'll select this living room JPEG. This is just a regular bitmap with one exposure setting. By default, any bitmap you put into the reflection slot automatically gets spherical environment mapping. I'm going to change that to cylindrical. Ideally, you would be using a panoramic image here in the reflection slot, although it's not strictly necessary. Let me view the image and show you what we have here. This is the same living room that you saw in Photoshop, but all of the highlights are blown out. I'll change the size to 1 inch in width and height to create a single tiled cylindrical environment map. Now I'd like to focus on the teapot, so I'll switch the render type to blow up and do a test render. Let me focus in on that teapot area and click OK. So this is just a regular bitmap in the reflection slot of the teapot. We're able to see some of that living room reflected in the teapot. You can make out the window area here with the curtains. You're also seeing the teapot reflect in the coffee table, which has noise in its bump channel. I'll clone the rendered frame window to make a future comparison. Now I'll change the bitmap parameters down here to use a different file. This time I'm going to change to an HDR image, livingroom.hdr. When I try to open that, I'm presented with this additional load settings dialog. And what you have to do is move this red bar over by changing the white point location. This allows you to step through the exposure. What you want to do is get that bar on the right side of the histogram, just like that, so that you capture all of the information that's stored in the HDR image. I'll click OK and go ahead and render. Now it looks a lot darker, but we are able to perceive more detail in the reflection. If I'd like to move through the dynamic range and reflect the scene at a higher lighting intensity level, I can do it. The way that's done is in the output rollout of the bitmap. Change the RGB level down here, and I'll try 40. Now it seems much brighter, and I can see it up here. If it doesn't look like this, you need to uncheck this mode so you can see the bitmap all by itself. We're looking at part of the rug, it looks like, here in the sample slot. I'll do another rendering, but this time let me compare the two HDR images at different intensity levels. Remember, the intensity was set here in the output rollout with the RGB level. Now it's much brighter. So basically we've bracketed to a higher exposure here where everything is brighter. And so we're getting more reflection without sacrificing detail. So there you have it. Use HDR images to capture more detail throughout the entire dynamic range.